Okay, in this lesson, we are going to learn about two new types of graphs we can use for quantitative data. Right now, all we really have formally is the dot plot, but we're going to learn about two more options in this video, stem and leaf plots, and then histograms as well. So we're going to talk about how to make them and how to analyze them. First up, we're going to discuss our good friend, the stem and leaf plots. Now, you guys have made these, I'm sure, at some point in your elementary, middle school career, or maybe this is brand new. I'm not sure. Stem and leaf plots really aren't bad. And there are a bunch of steps right here that you guys can just read and have just basically so it's there in your notes. But I want to talk a little bit. I'm going to sketch a quick mini problem off to the side to remind you guys about what a stem and leaf plot is. So let's say I had the numbers for my data set 22, 22, 24, 26, 29, and I was graphing these numbers. The way stem and leaf plots work is you end up having the stem on the left side and the leaves on the right. So if I were going to have a 22, I would have a 2 on this end and a 2 over here. That would represent 22. If you have a second 22, I would have another 2 on this side like that. That'd be another 22. Then it'd be a 24, and it'd be a 26, and it'd be a 29 like that. But when you write a stem and leaf plot, you don't automatically know, oh, that's 22. It could very well be where this is 2.2 or something like that. So whenever you make a stem and leaf plot, you need to have a key on the side where you explain what a number represents. So this would represent 22. And then you'd have context, if this was age, 22 years or something like that for the problem. Now, when you make a stem and leaf plot, if this was my data set right here, having just one row doesn't really do too much for me in terms of making a comparison. So what you will sometimes see is you can actually split them up. If they all start in the 20s right here, you may have two separate rows for all of the 20s. And then what you do is you split it down the middle. So 20, 21, 22, 23, 24, those would go in the first one. And then 25, 6, 7, 8, 9 would go in the second one. If you split a stem like that, you need to make sure that you keep the same number of digits in each. It'd be kind of dumb if it was 20 and 21 for the first one, and then 22 all the way through 29 in the other one. So those are all things I will address with you guys. But if I were to do that for this problem, the split would happen at 24, 20 through 24, and then 25 through 29 for the next one. So then what I would have is I would have 26 and I'd have 29 right there. So a couple additional things to write down about these, and then we'll do a bigger example here. When you make a stem and leaf plot, you need to make sure that, assuming you have a reasonable amount of data, generally you want to shoot for somewhere in the neighborhood of 5 to 8 stems. This isn't a set in stone rule. My stem and leaf plot right now only has 2 stems to it, but my data set is so small that I couldn't really get any more than that going on. If you do a stem and leaf plot and have 2 or 3 stems, you're not going to be able to look at that graph and tell what the shape of it's going to be. So you need to have enough different groups that you can start to see the shape of your overall data set. You don't want to have too many groups though, because if you go to the other extreme, what'll end up happening is you'll just fragment your data so much you won't be able to see anything. So in general, 5 to 8 rows is a good number of things to have. If you split a stem, which I showed you what that looks like over on the right side there, if you split a stem, each one needs the same number of leaf digits possible. That's a wordy way of saying that if I'm going to split 20 to 29 like that, I need to split it down the middle. So each group has the same number of possibilities. You wouldn't want to go 20, 21, and then 22 through 29. You split it so they have the same number of options possible. The last thing I want to write down on this slide in terms of tips is that to make things easier, you are allowed to round, so you can round or truncate to make life easier. So you guys should know what round means. Truncate means instead of rounding, you just chop the decimal. You just drop it all together. So if I have a 22.4, it's a 22. If I have a 22.9, it's still a 22. So when you have data sets with weirder gross numbers, like if there were decimals on here, you could chop those decimals for the sake of making the data set easier to analyze. So you don't have to use the exact number if it would make you have way too many different stems. One other thing in the list of rules right here that I want to make sure I emphasize again. When you make a graph, it is really important. Like, I shouldn't have to sit there and try to figure out what you're saying with your graph. Everything needs to be labeled well, which means you need to make sure you have a key for your graph and that key includes context. So definitely important when you make a graph that you're giving a good key. So let's go ahead and tackle a fresh example here. We're looking at the height of 14-year-olds from the UK, and we have male and female heights, and we're going to compare these two different distributions to see if there is a difference in height between these two groups. So you can look at this list of numbers and maybe stare at it for a while and be like, it seems like this list is higher or this list is more spread out. But it's so much better and so much easier to make observations like that when you look at a graph. In AP statistics, you'll never have a situation where you just make a graph and it's like, hey, I'm done. I made my graph, because what's the point of doing that? We make graphs so that we can analyze situations and draw conclusions from them. So you will never have a problem where it's just like, oh, make a graph and it's over. You always are going to try to look at your graph and figure out what's going on. So I want to start us off on this graph here, and then I'll finish it off and have you guys finish it yourselves. But they say to make a back-to-back stem plot. So let me show you what that looks like. Those are the same lists of numbers right there. Instead of having two entirely separate stem and leaf plots, we're going to do what's called a back-to-back. In that situation, our stems are going to go in the middle. So we'll have stems in here, we'll have one list of numbers over here, and we'll have one list of numbers over here. So this can be the male list, and this can be the female list. It doesn't matter which way you do it. And then we're going to have the stems right here in the middle. So let's talk about our list of numbers here. If you look at these numbers, everybody's in the 150s, 160s, 170s, and there's a 180. Those are the only four things that we have going on to start. So if we were to go just 150s, 160s, 170s, 180s, that's only four stems long. One of my tips was that generally you want 5 to 8 groups. It could be a little more, it could be a little less. It's not the end of the world. But 4 might be a little bit small, where it's too hard to see the shape because it's all scrunched together. So what I'm going to choose to do instead is split each stem like I talked about in the last video. So my first stem is going to be for the 150s, and I'm going to have a second stem for the 150s as well. So this is going to be 150, 151, 152, 3, 4, and then the second one is going to be 155, 6, 7, 8, 9. So you take each kind of chunk of 10 and split it into 2 groups of 5. When you make a stem and leaf plot, you need to be consistent. So when you're being consistent, that means you can't be like, oh, I want 2 here, but only 1 here. You also can't skip anything. Say nobody was in the 160s, you still have to include them on your graph. So my graph is going to look like this. I'm pretty sure the tallest person is just the 180. No, there's a 183. I'm going to do 2. Oh, there's a 187 as well. So I need the 218s. All right. So I've got myself my stems. Now let me show you how this will begin. And then after I do that, I will skip ahead so you guys can see the finished product here, and you can do it for yourselves as well. When you do these and you put your little leaves right here for males and for females, you need to make sure the numbers are organized in order. So least to greatest, ascending order. So I need to find the smallest number, and I wish I would have had the list of numbers in order already, but I did not. For males, I see a 151 and a 154 and a 157, and it's a good idea to mark these as you go. There's a 159. So these are all my 150s numbers here. So I got to put them least to greatest for each line, and make sure when you do that, you space them the same way. Don't do different spacing for different lines. So I'd have a 151. I'd have a 154. The 157 is part of the next group, as is the 159. So I'd have the 7 and make sure it's lining up. So these are like nice little clean columns right here. And then I've got 159 right there. When you eventually get to the female data sets and you're putting those in order, so for the females, I see 152, 57, 58, 53. So as you're putting the females in order, start from the inside right here. So this would be my smallest number is 152. Then I have a 153, and then I have another 153 like that. So I'm going to have my two groups on either side right there. And then go ahead and pause me, do this yourself, and then mark the numbers as you go. I'm going to pause myself and come back with the solution all written out. All right, so I'm back now with my finished graphs right here. As a quick sidebar, AP Stats doesn't spend a lot of time making graphs. This is not a big focus of this class, because honestly, if you're going to do something with statistics in this day and age, you're not going to sit there and make a little stem and leaf plot by hand. You're going to take your data, throw it in the computer, and the computer's going to make a nice graph for you. So don't like freak out about like, oh gosh, this is going to be so tedious. We're going to do this forever. You need to know how to make them, but in real life, and even in this class, after we learn how, we're pretty much going to use technology to make graphs for us. It's a lot more important that we can read a graph and analyze it, because I could see a problem where they would give you this picture and ask you to talk about what's going on. Remember that our job is not done when we just mention, like, you're not just going to make a graph and walk away. You're going to talk about what you see in the picture and kind of describe the situation going on. And in order to do that, we need to use our good friend socks. So with this picture right here, we are asked to compare these two distributions. Anytime you're comparing a distribution, you are going to use socks. I'm going to talk about this out loud, and then I'm going to pause myself again and show you guys my little model solution for how I would word this. Let's talk shape first. When we look at the shape, I'm going to start on the female distribution. For the female distribution, it's a little dangerous to talk about shape as is, because the numbers are sort of backwards when we have it over on that left side of the picture. So what you need to do, like if you tilt your head, it sort of looks skewed to the right. Like if you look at it, so you're looking at the red. But the trouble with doing that is the numbers that are most common are the bigger numbers. So if I were to picture like transferring this over to like a dot plot, most people are over here in the 160s. There's lots of those. And there's less people in the 150s. So if you think about what this represents on a normal dot plot, this is a left skew. The numbers where it tails off are towards the smaller numbers, if the smaller numbers are on the left. So this is a left skew. Or another way of saying that, what you'll sometimes see is you'll talk about a negative skew to the data set. It's skewed towards negative numbers. Okay, so that is the shape for the female distribution. The males, on the other hand, are a little bit trickier to analyze. I would argue that this shape right here is roughly symmetric. I would say that because like if there was one extra number right here, it's almost a mirror image on both sides. Yes, this 7, there's like one extra number here, but if I were to like slide this guy right there, it's not far away from being the same on both sides. And I don't see compelling evidence of a skew in one direction. If you're like, oh, I'm not sure, is that skewed, is it symmetric? You could just sidestep the whole issue and just call it unimodal. There's one peak to that data set. You're still addressing shape by doing that, and you're not having to take a stand on something that's a little bit dicier, okay? So roughly symmetric or unimodal would both be good answers there. In terms of outliers, we have not yet learned an official way to calculate outliers. That comes later in this chapter. So we're just using the eyeball test. Neither distribution appears to have any outliers. There are no numbers that are so far away from the others that they seem like kind of crazy. 187 versus 183 just isn't that big of a difference in my opinion. For the center, we haven't officially learned about the median and mean yet, but we could use one of those two things for this data set. The median actually isn't that bad to figure out. Now that our numbers are in order, we can just count and figure out where our middle number is. So I'll show you how that would work, and I do this in another video with you anyway. But if we talk about the median, or the center, you could just toss out it's about this for each one, but we might as well discuss this now. So if I look, that's my smallest number, that's my very biggest number, next smallest, next biggest, next smallest, next biggest, and just work through the list like this, and you will eventually figure out where the median is going to be. So you can work through the entire data set like I'm doing here. Gotta make sure I'm talking and not messing up when I do that. All right, so that guy is the median. That's a 163. Another clever way of doing that, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have 21 numbers for females. If you have 21 numbers, number 11 is dead middle. I have 10 here, number 11 in the middle. So if I just count, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You can do the same thing to find the median over here. And then the last thing is the spread. This data set is a lot more spread out than the female data set. And you can talk about that as well. So I'm going to pause and come back with a little paragraph answer for this problem. Please make sure when you do this, you remember context and you explicitly compare your two distributions. Say which one is bigger, which one is more spread out, etc. All right, so as you guys can see on there, I wrote out a kind of model solution of what's going on. Make sure that when you do these, you mention context like I did. It's also good to talk about the distribution of male and female heights. Some people just say male heights are right skewed, female heights or whatever it's going to be are symmetric, whatever. The distribution is what we're actually analyzing right here. So that word should make it into your answer. And then when you get to comparing the centers, I use medians right here. You could have just said the center is about. Even in my problem here, if you wanted to be extra safe, if you're like, oh, I don't know if I messed up my medians, you can put about or squiggly by this. And sometimes that'll actually save you. So like if you screwed it up, but you're close, they may not take off if you do that. So you can compare the numbers, explicitly say which one is bigger. And then I have my answer for spread up here. So yeah, it looks like male heights are higher on average and they're more spread out. Females tend to be more consistent. And then the heights average overall isn't quite as high. So that is the basic setup of a stem and leaf plot. And I can't remember if I said this earlier or not, but make sure you include a key on your problem. We mentioned that earlier. I did have mine over here, but I can't remember if I said that already. So that is a stem and leaf plots. Let's move on to our second type of graph of the video, which is a histogram. And a histogram is basically a fancier version of a bar graph. When you make a histogram, what's going to end up happening, what's going to end up happening is your x-axis is essentially a number line. The y-axis is going to be frequencies, so or relative frequencies, how many there are. And histograms look like bars like this that are connected to each other. So it's sort of like a connected bar graph. I will give you more info on how this works as we go through it. But when you make a histogram, you need to make sure that you always have your bars going vertically like this. It doesn't, we don't like to see histograms going this way, so that's bad. When would we prefer a relative frequency to a regular frequency? Almost always. Especially when the numbers are bigger. If I want to look at a histogram of the unemployment numbers in the US, it doesn't really make sense. I wouldn't really want to see raw numbers because I wouldn't have an appreciation for what that means. But if I hear that 15% of people are currently unemployed, that is easier to process than saying 4.6 million or something like that. All right, so let's go ahead and take a look at an actual example of using a histogram, and I'll show you how these rules work as we jump in. So when you make a histogram, we're going to be making a histogram for the 30 teams in the NBA. And then it says to make a dot plot and use your dot plot to make a histogram. We might do that, we might not. But basically, let me just show you conceptually. I don't think I want to make a full-on dot plot right here. But let me show you conceptually what it means to make a histogram here. So suppose I started out by making a dot plot, and then numbers, the data's on the next slide, so we'll get to that. But let's say I had teams that were here. So there's teams with this many points, and then I had some more teams over here like this, and I had lots of teams who are around here, and then I had not so many teams who scored this many points. What a histogram does is it basically takes all those dots and it cleans it up and puts them into like little bins. So this bin would go up to the height of 5 because there are 5 teams that are in that general range. If there are, I shouldn't have put 5 dots here. Let's say there are like 2 teams right there. Or I have 1 team right now, the next bar from here to here would only go up to 1 because there's only 1 team who has numbers in that range. So say this is 60 points, this is 65, this is 70. There'd be 5 teams that are between 60 and 65, but only 1 team that's between 65 and 70. And then my next group, if it's got all those teams in it, would be like this high, etc. So you can picture a histogram as like a bar that counts how many dots live inside of it. That's a little bit confusing maybe, but it'll make more sense as we do our example. So here is the actual table that we're going to work with. Very first step when you make a histogram is figure out the smallest number and the biggest number so you know what you're working with right here. And when I search through this list, the biggest number and the smallest number, I see a 106. That might be the biggest. No, I have a 106.1. So that's my biggest number. And then my smallest number, I see 93.2. Looks like 93.2 might be the smallest. I don't want to have to redo this though. So let me scan one more time right here. Yeah, there's a bunch of 93.2s, but that does appear to be the smallest number. So we have to go from 93.2 to 106.1, it would appear. When you make a histogram, just like with the stem and leaf plot, you want to have 5 to 8 stems in general, and it usually makes sense to start at a nice round number. So I'm going to start at 93.0. And then what I'm going to do, this is very informal right here, 93 to a 106, or I guess I'd have to go to 107 because I have a 106.1. 93 to 107 is a distance of 14. And if I'm going to try to get 5 to 8 groups, I might go by like 2, or I might go by 3 or something like that. So I'm going to choose to go, if I go by 2s, that's going to put me about 7. That's probably pretty decent. If I go by 3s, I would have 5 groups. That might be a little small. So I'm going to go by 2s. We'll see. Making these graphs by hand is somewhat informal a process. So I'm going to go 93 to 95, 95 to 97, 97, 99, etc. And just break it up into little categories right here, like I am doing. I'm dropping the decimals, which technically should still be there, but yeah. Okay, so I have my groups. Now, when you make your groups right here, you'll notice like what happens if you're exactly a 95, or what happens if you're exactly a 99? Where do you go? If you land on the boundary exactly, you go in the smaller or the left of the 2 groups. So if I have a 95, 95 is going to fall into, actually I said that kind of weird. Don't listen to that, listen to this. If you land exactly on a number, you choose the one where it's the left boundary. So a 95 would go in this group right here. A 97 would fall into this group right here. A 99 would fall into this group right here, and so on. So let's go ahead, and what I'm going to do is start counting and putting tally marks for each team. So the Hawks, for example, very first team are on 98.0. 98.0 falls in that group right there. Then I have a 96.5. A 96.5 would be in this group. And then go ahead and put tally marks for all 30 of your teams. I'll do it over here. All right, so I went through and I tallied all these up. Not a terribly fun process, a little bit tedious. And then what I did afterwards is I wrote down the actual number for each, and I double checked myself because it's super easy to miss one or lose your place. I do have 30 teams altogether, so I'm pretty sure I did this one correctly. If there's like one number you have different than me, it's not a big deal for right now. There was one team, the 103.0, that landed exactly on the edge or boundary. The 103.0 when landed in this group right here. So there should be a dot here and not 6 over here. So once you do that, we're going to be ready now to make an actual histogram with our data sets. So what I'll do is I'll go to the next page where I have more space, but I will leave my nice little picture right there so I can very easily reference it. When you make a histogram, your x-axis is a number line. I said that earlier, and it's something people screw up quite frequently in class. So when you make your picture, guys, I will incorrectly see people be like, oh, this tick mark is 93 to 95. Oh, this tick mark is 95 to 97. That's bad. Don't ever do that. What you need to actually do is treat it like a number line, meaning that each tick mark only gets one number on it. So I got myself my x-axis here. I would have 93, then I would have 95 for my next mark right here, just like a regular number line in math class, etc., etc. So I'm going to go ahead and put my number line right here. I got to make it to 107 and make sure that they're spaced about the same. It's harder to do on this tablet, but you get your spacing going on right there. And then my y-axis is going to be either frequency or relative frequency. This is a rare situation where I think frequency is actually just fine. There are only 30 teams in the NBA. Most people know there's only 30 teams in the NBA. So if I hear 4 teams or 7 teams, that's not so bad because I know there's only 30 and it's not that many. If this was a big problem, what I could do is I could take each of these frequencies and divide by the total. So I could take, for example, 9 out of 30, which I believe is 30%. And then I could graph a 30%. So I'd have percentages going right here instead of having the raw numbers. But I'm going to keep it simple and go just straight up frequency for my y. And I would have anywhere from 1 to up to my biggest, which is the 9. So let me show you how you actually make this picture now. When you make a histogram, the bar from 93 to 95, 9 teams live in this area right here between 93 and 95. So your bar is going to go between 93 and 95, and it's going to go up to a height of 9. So the bar goes in between those two numbers, and 9 teams live in this range right here. The next group is 95 to 97, and 5 teams live in that range. It's a connected graph, so I just go 95 to 97. So this, between these two numbers, there are 5 teams who live in that range, and then I have another 5, and then I have a 2, a 5, a 1, and a 3. So my graph looks something like this. It's worth noting that if you went by something different, so at the beginning of the problem, I went by 2s. If you went by 3s, you could very well see a different shape to your graph. So when you're asked to make your own graph like this, we could end up with different looking answers depending on how our pictures look, and that is okay, that is normal. But based on what I have right here, let's talk about the distribution. I'm not going to write out the whole one this time, but we should at least address it. As far as shape goes, I would say very clearly, this does appear to be a right skewed distribution. There's a few bumps along the way right here, but it does appear to be sloping downwards with the most popular values over here. So right skewed distribution, the distribution of average points per game in whatever season for the NBA is skewed to the right. There don't appear to be any outliers in this distribution. Nobody's separate all by themselves. There are 3 pretty high teams over here. Next up, center. If I were to talk about the center right here, this might be one where I just ballpark it. The center is somewhere between 97 and appears to be somewhere between 97 and 99 points per game. Or I know there are 30 teams. So there are 9 teams, the lowest 9 teams. This would be the lowest 14 teams. So the 15th, 16th team are somewhere in this range. So the center is somewhere in between here and here. And values vary from as low as 93 to as high as 107. Or I can actually look back at my numbers. I think it was 106.1 and 93.2, where you could actually say they vary from here to here if you wanted to. So you would just talk about the shape, outlier, center spread of this graph, and it's pretty good. The last thing I want to talk about in this video is how you make a graph like this on your calculator. Because making a histogram by hand is awful. I might make you do it on the one quiz just so I know you know how, but never again after this quiz will I make you make probably a histogram. It's going to be a situation where I give you a histogram or you can use your calculator to help you out. So let's talk about how that works. I'm going to go ahead and go to my calculator here and pull it up on the screen so you guys can see. Hopefully you have one to follow along with me, but if not, at least pay attention to it. To type data into your calculator, you're going to go stats, edits. We've used this before when we do like linreg and algebra 2. And what I'm going to do is just type all 30 of my numbers in right here, and I'll come right back with a full list. All right, so I got the list typed into my calculator here. When you type in a big list of numbers, be very careful. It's easy to miss a digit and have like a 9.2 instead of a 95.2. Also, to make sure you didn't just straight up skip a number, when you get to the last number, if you have it highlighted, it tells you I'm on my 30th data point and there were 30 teams. So you can check pretty quickly to make sure you actually have all the data typed in. Once it's typed in, you're gonna quit out, second quit. And usually in math, like regular math, we go to y equals. If you go second y equals, this is the stat plot menu where you can actually graph different things like histograms on your calculator. So what I'm going to do, I went second y equals, and I'm going to hit enter on the first choice. I'm going to turn the graph on, so I click enter on that. And for type of graph, I'm going to select the histogram, which is this third option right here. So I'm going to choose histogram. My X's were in L1. That was the big list I typed in, which is cool. My frequency, I'm just going to leave that alone. When you hit graph, you're probably going to see nothing. Or if you have lines saved in your calculator in the regular y equals, you can delete those out. Notice that plot 1 is now dark because I turned it on. When you're looking at your graph, you want to go zoom. And the best choice for this is zoom stats. It's a nice option for our class right here, which is number 9. If you do zoom stat, it's going to pop up a little histogram right here. Now you can actually take this histogram. So you see the right skewed distribution we saw earlier, but you can click trace. And if you click trace, it's going to show you the min and the max for each group. So this first group goes from 93.2 to 95.35 right now. And there are actually 10 numbers in this data set. Ours had 9 for that first group, but we were 93 to 95. So depending on how you structure your group sizes, you will have different amounts of numbers. I like that the calculator says that the max is less than this number right here, 97.5, because if you had exactly that 97.5, it pops you into this group. So when I wrote those out earlier, 95 to 97, I probably should have gone 95 to just less than 97 like the calculator is doing here. But anyway, you can kind of see where those numbers fall. And if you want to manipulate how big the groups are, you're going to go to the window. Right now, it gives you the min and the max, and it's going by 2.15s. If you're like, I want to go by like 3s for my graph, I can change the X scale. And if I do that and click graph again, now it's going by 3s instead, and I can go by different amounts and play around with it and make it like I want. Making these graphs by hand is terrible because you're committed to doing it one way, and if it doesn't work out great, you're kind of out of luck. The calculator is nice because you can very clearly play around with it and be like, oh, I want to actually go by like 7s. And if you make your graph too big, like I went by 7s right there, this shows you again, too few of groups. You can't really tell shape anymore. So it lets you play around with it, which is really nice. So yeah, we will use our calculator for making graphs, which is great because it's something we get to use on the AP test. We also have plenty of websites out there that can do the exact same thing. So it's important that you understand how to make a graph by hand, and I might make you do it once on a quiz, but in general, we will use technology to make our graphs for us because we have bigger and better things to do. So that is the end of this lesson.